Okay, so record already. So you follow this, open your file. The file it's in, where's the file? So you need to wait for it for a while. This is the Autodesk showcase. In my opinion, the SolidWorks one is better. Okay. It's taking some time. Converting. Oh, forgot to tell you. This Autodesk, you can actually go to View. You can add in the shadows. Oops. You can add all the shadows. You can add in the reflections. You see the reflection coming out already? Yeah. You can also go to the settings and adjust the opacity of the reflection, the blurring, the height offset. Okay. For example, you want maybe 4 or 10. Can you see the shadow goes further and further away? So it looks better in a sense. Okay. Something like that. You can explore all this. Is it done? Yes, it's done. Now the rendering in this, okay, then basically you need to go through all the icons here. So you open the file already, right? Second one, say the lighting environment. So you can choose an environment that you like. Okay. Country road. Okay. Okay. Right. You can choose the lighting. Now the lighting is the one. You can adjust the level. You can adjust the lights. Click on the light. Can you see? I'm moving my light, right? The shadow seems to follow my light. Can you see? I put my light here. You see? Can you see the shadow is moving also? So let me put my light directly above the car. Okay. Control plus click. Okay. So it's done. Shadow. Actually, I shouldn't adjust. Just now that one was the best, right? Okay. Anyway, you know my idea, yeah? Okay? Adjust the brightness level, okay? As bright as possible. Wow, like that is the best. As though the bright sun is shining on it. Okay? Then you go to the visual styles. You can play around with this, but I think it's very good already. Yeah? Okay? Now it's very important, you notice one thing. For a car to actually have a glow, you look at this car now. Where are the parts that are glowing? The curves, right? So just now if you never round anything, I can assure you it's going to be boring. Because when there's a curve, when light hits it, according to science, you know, when it's curved, when the light hits, all reflected at different angles, right? So it will create a very nice reflection. Light glowing. If it's flat, the light hit, homogeneous. Common sense, okay? So it's important to do all the roundings that you need, okay? Then you can play around with this, and last one you publish to an image, okay? And the image you can make it, you can adjust the resolution. For example, if you want a super big poster, you can adjust this to 4000 by 3000. I always adjust to 4000 by 3000. Oh, sorry, 3000 not 300. Okay. Then you press publish image. Save the image out as maybe ES Spring 27 May. Okay, and it's publishing. It's actually very fast also. Okay. The image is of, because when I blow out the image, can you see the image is of very high quality. There's no pixelation. There's no pixelated. See? Even because this is the full image already. This is the full size already. There's no pixelation. Okay? So this is very good for a poster. Alright? Now, I'm going to go to what? Yeah, what's the question? What? You will publish and you will save it in one of your folders. You can save it in any folder you specify. Okay. Last one, the design module. Okay. Now the design module, it's, let me switch this module off. This one is very useful for you, seriously. Okay. So I don't save this. Okay. Next one is the flow design. Wow, this one. Flow design must go to environment. Now if you go to your environment, you won't see this flow design, because like the showcase, this flow design is also a separate software, also under Autodesk. Okay, right? So you go to flow design. This is for the virtual testing. The virtual testing. This one is a lot easier to use than SolidWorks. Okay. Now over here, when you start out with your own, if you manage to install this, when you switch this on, you won't see this, because for mine it's already configured already. So every time I press, it will show the same configuration. Some settings. Now what are the settings? Now do remember, these are the things you need. Okay, first you must go to simulation settings. Make sure that your wind speed is 20 meters per second. Now do remember that our car needs to raise 20 meters in approximately 1 second plus. So we expect the wind speed to be about 20 meters per second. So just make sure that this is constant. So make sure that this is about 20 meters per second. Resolution wise, we don't change, it's about 100%. Click OK. Alright. Next one, wind tunnel orientation. Wind tunnel orientation, please make sure that your wind tunnel orientation is correct. How do you check whether your wind tunnel okay. Yes. This box is where your air is testing. Now you do not need to test the whole area. You're only interested in the air immediately surrounding the car, right? Right now. So this box basically defines your car. Can you see that this box is where I want the car to be? Okay. So you can shift this. Wait, how do I shift this fellow? Sorry. Shift the blue arrow, I think. Oops. Okay. Oh, no. Let's put this to 0. Okay. I think. Oh. Sorry, yeah, there is a way to shift it. Yeah. Okay, one more time. This one you can, if I'm not wrong, you can shift this. Okay. Anyway, your job is to make sure that the wind tunnel orientation is here. Okay. Okay. Next one, the 3D simulation. Now, before you start the 3D simulation, you also need to you can actually know the pressure and the velocity. So what you can do is you click on the 3D simulation, then it will simulate for you. There's a drag plot that you can see. This drag plot. Can you see that these two lines are basically your job is to get this average drag coefficient. The software will help you calculate the average drag coefficient. Your job is to get this average. Can you see that the drag coefficient is changing? It's changing. 0.876. This one. .865. Yes, it's for whole car. Now this car is not complete because the wheels are not in there. Alright. So what this is doing is the software is actually trying to find the best drag coefficient. It's calculating, it's simulating. Okay? Right. So when will you stop? Simple. When the two lines meet one, that's the ideal case. But we realize that this one, after waiting for 30 minutes, still haven't converged. According to the program, according to the instruction, you're supposed to touch. So normally what we do is, after 5 minutes, we just read the drag coefficient, then we stop. Make sure it's a fair test for everybody. Means every test you do, must wait for 5 minutes. Okay? As long as the condition of testing is the same, it's still considered a fair test in the area of science. Right? Okay? So my drag coefficient, this is about the drag coefficient. You can also, the surface pressure plot. Okay. Now, red surface means is of high pressure, as we can see. High pressure. Does it make sense? Yes. Of course, this is the part where the wind hits directly, right? Okay? So your job is to make sure you get less red and more blue. Okay? We want more blue. Right? So this one, although you really need a very good expert in aerodynamics to come and explain all these things, but for you as a newcomer category team, if you are able to do these kind of things and put them in a folio, you will definitely win all the other newcomers. Unless there's also a newcomer who also know this. Okay? Right? So I highly suggest you to do this. Then you also can do the flow lines. Okay, let me get this drag plot away. Wait, how do I close this? Okay, let me get this drag plot and the surface pressure away first. And flow lines. Now the flow lines can be, this is flow lines. This is particles. Particles is not very good. Okay. I think flow lines is better, right? Okay. You can go to flow line settings. The count. Currently now I only have 64. You can increase this to 200. Okay. Then you press OK. It's a bit lag. Alright. So this is something like that. Okay. And then you can finish the flow design. Okay, now I'm going to show you a little bit on the SolidWorks part. Because the Sec 2s, you are in a competitive category, right? Competitive category, I guarantee you, all the teams in the competitive category will do this. You're not novice anymore. I don't know. Okay, anyway, I want to share with all of you here. Yes, I think I should share with you. Okay, because later you'll go there, you'll get wet upside down. Now, for the rest of you, can you use SolidWorks or not? You can use SolidWorks also. But let's say you finish, okay, example, if you finish a car, example, if after following my tutorial, you can get something simple out, okay, like that. How are you going to take this software, this file, and run it in SolidWorks? Well, there's a way. You have to save as, you have to export your file. Sorry, this, am I still under record mode? Yes, you need to export this to CAD format. Export this as a step file, STEP. Step file, this one, STEP file. The step file is the file that links between the softwares. Save as a step file. Close the software. If you have SolidWorks, which is quite easy to install, sorry. Open up the step file. Sorry, I opened another stat file. Anyway, if you open a stat file, it's somewhere there. Okay. Now this stat file, this is a SolidWorks program. It's almost the same, yeah. But this one never hang on. So far, they never hang before. You save as the SolidWorks file. For this one, save it as a SolidWorks file. Okay. Now, for those of you, if you want to do the simulation, it's over here. Add-ins, SolidWorks Flow Simulation 2013. You'll see an extra tab coming up. You see Flow Simulation coming up. Go to Flow Simulation, go to Wizard. This one, just press next. Next. The only thing here is external. We are not doing an internal analysis. We are doing external analysis. Okay. This one you press exclude, exclude. Now, where is your air flowing? Your air is flowing in the Z direction, right? So your reference axis here must be in Z to tell the computer that your air is flowing in the Z direction. Can you see here? The car is facing the Z direction, right? Next. The gas that you're simulating is air. So click on air and add the liquid in. Okay? Because the computer needs to know what fluid are you testing against. This one next. Okay, here there's something. Now the velocity in the Z direction will be minus 20. Because if you put 20, the air is in line with the Z. You put minus 20 so the air is going the other way. Okay? Now, that's all. Next, finish. Okay, so this is done. Now, next thing, you can run the simulation now. Run the simulation. Run the simulation. So while you're waiting for it to run, it's preparing the model now. So the competitive teams, if they're still using SolidWorks, this is something you must do. If not, you'll get whacked. Because the other teams will do this. The other competitive teams will all do this. Definitely you don't want to lose out, right? You cannot go to the competitive team, then you go there, you get bronze. Definitely you don't want that, right? Okay. What happened? It's preparing the model until so long. Is it because, okay, hold on. Hold on. Let me stop the calculation. Maybe the file have to be done in real SolidWorks. Okay. Oh yeah. Let me start a new file again. Yes, that's one. Okay, let's try again. Flow simulation, wizards. Sorry, let me try again. Okay. Now, before you actually run this, there's this thing called goals. The goals here. Insert global goals. Now, there are many goals that you want. There's a lot of data that you want from the results. Hang already. Okay, one more time. SolidWorks. Let me finish up the SolidWorks flow simulation, because if you are using SolidWorks, you will need to do the flow simulation. Okay. So, example, if you finish this, remember to go to add-ins flow simulation. Did Miss Wendy teach you all last time on this? No. So go to flow simulation, wizard, next, external simulation. The reference axis is Z, because your car is facing the Z axis, in line with the Z axis. The gas is air. This one don't need. The velocity in the Z direction is -20. Okay, that's all. Then you will need to go for the goals. Wait, because you need to do the goals. Insert global goals. What happened? Always come here hang. Yeah. Too many already. This laptop is supposed to be a very good laptop. There's got 10 gigabyte of memory inside. memory. But then also like that. Okay, tell you what, the goals is where okay, let's give it one more time. I'm not going to do the goals. I want to show you the flow simulation. Okay, one more time. One more chance for the software. Okay. This one you got to see. Well, I'm not going to go to the goals. I'm going to run the wizard straight away. Hopefully it will run better. This one should run. Okay. This one there's something allow access. Okay, now this one there's a lot of iterations. It's doing the calculation. This is the iteration. Currently it's 0. It will simulate many times. Okay, so iteration 1. So you can, example, maybe do a few iterations, maybe about 50, maybe about 100, I don't know. Okay, but for time's sake, we are going to stop the simulation now. So you stop the simulation. Do you want to save the result? Yes. And you wait for it to stop the calculation. Okay, so the solver is finished. Close it. Now this is the interesting part, the results. You can actually go to this one, go to flow trajectories, right click, insert. Now the flow trajectory is the part that is the most interesting. The appearance lies with arrows. Select this surface, select a few surfaces. Okay, select 3 surfaces. Then you press OK. It will calculate the flow simulation. You will calculate a flow simulation. Now, if you are not too satisfied with the lines, you can actually go to edit again. Go back to the previous screen. Just now was 20, right? Let's change this to 40. Example. So you'll see more arrows. Lines with arrows. I think this is the best. Okay. Press OK. So you will run a study. Now you can actually go for simulation. Go to the flow trajectories here. Right click. Go to animation. You can play this. Okay. Simple one. Then you can also do other cool things. You can wait, stop doing again and again. You can, there's a record button here. You can record the animation. Okay, go and explore this. Right click and play. If you play, it will just be normal. Yeah? Okay. Alright. So it's quite cool actually. Okay. Now all the competitive teams, they will have this video on iPads, laptops, and they will have many of these, because if I'm not wrong, they will always have one person dedicated for this thing. His or her job is to sit down there and do a lot of this kind of thing. Whether it makes sense to them or not, I don't know. Maybe the judge will ask you, so what do you understand from here? Then they got to talk about it. Okay. Now, what else can you do? You can do this thing called a surface plots. You can insert a surface plot here and press OK. I think surface plot wise, I think is the definition. Must go to options. Yeah. Surface plot is about, hold on. Oops. Okay. You can play around with all this stuff, yeah? Okay? But the animation is one that you should have. Okay? To show the air moving around the surface. Whether it makes sense or not, I don't know. But it's good to have all these things to show how the air is done. Okay? Autodesk is the one just now we saw. Inventor can, we just take a video. That's why I like Solid better. It's better in this way. Okay? And last time did Miss Wendy go through the rendering with you also? Now for this one, it's very simple. You can actually, any modification you can modify here. For example, I want to round a corner. Example, I can round a corner. Example, can I round this corner? Can. You can go and round this corner. You see, after I round the corner, I go to flow simulation again. I run the simulation, I get a new result again. You don't need to redo again and again and again. You make changes, you run the simulation. It will show you all the simulation. Okay? Now, last one. Before I go, I want to go through the rendering. Now, rendering is something that you all did the rendering like that? Sure. My rendering is more powerful than. My rendering is very powerful one. I'm afraid she. Okay, because last time due to constraint, maybe she didn't do this. You have seen what Autodesk rendering can do, right? If you think that's good, then you should see this. Can you stop this already? Can you stop moving already? How to stop? Good question. Stop. Okay, let's stop this. Okay, last one. To go for the rendering, you have to let us remove this. Then you go to Photo View 360. Photo View 360. Press OK. Then you will see this new button called Render Tools coming up. Go to Edit Appearance. Select an appearance you like, maybe plastic, high gloss. Choose red color. Put here. Oops, sorry. One more time. One more time. One more time. Edit appearance. Okay, before you do this, actually you're supposed to go to this integrated view. If you still remember this view, those of you, you should click this button here. If you never click the render tools, this will not appear. Okay, click this, and then you wait. Please make sure you use the best PC for this because it requires a lot of processing power. Okay, it's generating my first preview. It's not finished yet, of course. Okay, now let's go to the appearance, edit appearance. You can go to high gloss. Let's choose blue. Whoa, power lah. The reflection, everything great. You can choose other materials. I mean, if you want to play, you can play lah. You can choose aluminium. You all didn't see this before, right? Oh, you never keep playing. You can go gold. Shook, right? Okay. For example, if yours is gold, you can go and edit the scene if you want. Edit any scenes you like. Maybe you choose this one. Example. Last one. Once you finish, you go to final render. It will just generate the preview out for you. Okay. Of course, you can edit the size. Yeah. You can edit the size. This one, it's more powerful than Autodesk. Sad to say. Yeah, it's definitely better. I think it looks better also. That's why the coursework, my whole school will always use this. Always they will get very high marks for this. Okay, right. So that's all I have for you. And so sorry that the software the Autodesk give us so much problem. And it's very important for me now to